Hi, in this video, we're going to learn how to use functions to make our code reusable and more readable. Let's take a look back at our 4 circles program. The 2 loops that we wrote are exactly the same. What if we were going to make a whole tower of these circles? We would need to write that loop over and over and over every time we needed to use it. This is where functions can help make our lives much easier. Functions are a way to group a set of commands so they can be called with one line of code. They are basically a way to teach Tracy new commands using the ones she already understands. Functions are very beneficial to us as coders. In the same way that loops shorten our code, functions only have to be defined once and then can be called as many times as we want with a single line of code. Functions make our code reusable by allowing us to repeat a set of commands anytime we'd like. Functions also break our code up into smaller parts, which increases readability. We use descriptive function names to make it known to the user what this piece of code is achieving. Before you can use a function, you must define it. This includes giving it a name and telling Tracy what commands you want to perform when you call that function. To write a function definition, we start by using the term def and then typing the name of our function, followed by a pair of parentheses and a colon. All of the commands we want Tracy to perform when we call our function must be indented underneath the function definition. Don't forget our naming rules when deciding on a name for your functions. Let's look back at the part of our 4 circles program we want to turn into a function. To define this function, we need to name it, and we've decided here to call it draw 2 circles, which follows all of our naming rules. Now let's take a close look at the indentation. Our loop is being initialized on line 13 and is indented because it is part of the function. Lines 14 through 17 are indented twice. Why is this? Well, one indent is to show that these commands are under the loop, and the second indent is to show that they are also under the function. We'll look at more examples of this in our code editor in a second. Once we have defined our function, we can call it throughout our code as many times as we want. Our 4 circles example has now been updated to show our function draw 2 circles being defined right after the speed statement. To be clear, defining a function does not mean that Tracy will follow any of the commands yet. Tracy will only complete the function when it is called. So if we look at our code, the first command that Tracy will actually follow after setting her speed will be pen up and set position. After that, we can see that the function draw 2 circles is being called. We are then changing Tracy's position and calling our function once more. It is very important to remember that functions cannot be called unless they have been defined earlier in the code. If you don't tell Tracy what you want to do when you say draw 2 circles, she won't recognize this phrase and will respond with an error. Let's go through an example to see functions in action. In this example, we want to enhance the X and Y axis program we previously wrote to now include hash marks every 25 pixels. Let's first focus on our y-axis. To place Tracy where we need her, at the top of the y-axis, we can write pen up, and then set position 0, 200. I want Tracy to face down, and she's currently facing right, so I'm going to use right 90. Now she's ready to draw my y-axis, and this will look the same as my x-axis, just in a different location. So let's write this as a function so we can use it again later. We need to make sure our function is defined before we use it, so I'm going to put it up here. I'm going to write def and then the name of our function, which we'll call draw hashed axis. Indented underneath, I'm going to write my code. The first thing I need is for Tracy to put the pen down and then move forward 25. Then she needs to turn to draw the hash mark, so I'm going to use right 90. My hash marks will be 10 pixels on each side of the axis, so I want her to go forward 10, then backward 20, then forward 10 again to get back on the axis, and then left 90 so she's facing down again. Let's see how this works. Did you catch our error? We defined our function but never actually called it, so let's add that in. After I send Tracy to the starting position, I want to call my draw hashed axis function. Now let's see if that works. Great! Now I want her to repeat these commands for the entire axis, so let's put a for loop in our function. Let's go back to where Tracy started drawing the hash marks and initialize our loop by writing for I in range. How many times are we going to need to repeat these commands to get all the way to the bottom? Well, we know our canvas is 400 pixels long and we've moved 25 pixels so far. So if we divide 400 by 25, we'll get 16. Now we need to indent all the code that is part of the loop. Let's run that and see what happens. Great! I now need Tracy to move to the beginning of the x-axis so we can call our function again. I'm going to make sure to lift the pen up before using set position, -200, 0. Then I want her to turn so she's facing right, so I'll use left 90, and then call my function again. Before I try my code, I'm going to change Tracy's speed so that she completes our code much faster. Great! In this lesson, we learned how to declare and call functions. Refer to the example we went through to help you use functions to solve some Tracy challenges of your own.